So today, guys, we are going to be looking at inequalities. Now, inequalities are generally not a tough section, but it is different to the equations that you guys know and hopefully are growing to love. So we're going to have a quick look at what an inequality is, how it's different from an equation, and then how differently it works and how differently it can actually be expressed or shown on a number line diagram. Whiteboard. All right. So inequalities. And remember, if you've got questions, feel free to type them in the chat. I have it open on the side throughout the whole thing. So inequality signs, you hopefully will know, is that sign and that sign. Now, what are these signs? Well, this is a less than sign, and this is a greater than sign. Now, just knowing that is actually not going to help you very much at all. But we need to know what we're actually saying with these. So these signs are used primarily to compare sides. So you're going to have a number or an expression on the one side, and then a number or an expression on the other side, and you need to compare their relative magnitudes in actual numerical size, not a number of terms or anything like that, the actual value they have. So, for example, if I give you the number 3 and I give you the number 5, which one is bigger? Well, luckily, that's not a strain for you guys. This one is the greater of the two. And therefore, we use this sign. So the 3 is less. Now, why do we use this sign and not this one? Well, when I was in school, I used to struggle tremendously with knowing which sign we need to use. Is it open to the right? Is it open to the left? It was just something that never stuck in my head. So the best way that I can suggest for you guys to use, and actually the way that I still use to this day, and I'm going to change this to an appropriate color, is using the greedy crocodile idea. So if you have a crocodile over here, and I know, trust me, that is one vicious looking crocodile. I totally agree with you. You don't have to tell me that. We can make either one of these signs into a vicious crocodile. And because this vicious crocodile is incredibly greedy, the crocodile is always going to choose the bigger number, because that's what greedy things do. They always choose more, more, and more, and more. So therefore, you can see that his mouth is always open to the bigger side, because that's the side that he is trying to go and eat. He is not going to sacrifice and have the smaller one because he's greedy. All right. So what about if we have something like this? I have the number, let's say, -3 and -20. What sign do we put in there? Blue for signs. Well, we need to see which is the bigger one. Don't be confused and think that 20 is bigger. Remember, these are negative numbers. So the more negative we're going, the smaller the number. So -3 is actually a larger number, and therefore my crocodile mouth is open to the left, which is the larger number. there are also two other signs that are related, which is this and this. So this is a less than because it's got that sign, but the line underneath it makes an or equal to sign. And therefore this is a greater than or equal to. And that's going to become prevalent when we start looking at possible numbers we can solve equations with. So you need to have a look at saying, can it be equal to, or must it be strictly less than or greater than? What if I say x is greater than 2? And I say to you, what values could x take on? Well, what value could x take on? I'm looking for a value greater than 2. How do I know it's greater? Because my crocodile mouth is open to x, meaning that x must be larger than 2. So type in the chat options that you have or that could be applicable as an answer for x. So we have some suggestions of possible answers. Let's write these down. So we've got an option of 3 that came from a couple people. Got an option of 345. We've got another option of 3. And then we've got another option of something. It's a bracket with an X and a 2. And if you look at that sideways, it could be a bit of a smiley face with a bit of a kafie on the top for the hair. I'm not quite sure. But yes, so the other option was 3 or more. And this is true. But this is still not all the possible answers that could be there. You say, but it has to be bigger than 3. It has to be bigger than 2. So therefore it's 3, it's 4, it's 5, it's 8, it's 200, it's 345, it's 1,000,000, it's 2,645,321. Yes. But again, that is still not all of the answers because you are only looking at whole numbers. What about 2.5? What about 2.01? What about 2.000000000001? Are these values greater than 2? Well, yes, of course they are. Most of us think naturally according to whole numbers, and that's fine because it's natural. But we mustn't forget that we could have decimals as well. So if we draw this on a number line, for example, here's my 0, here's 1, here's 2, here's 3, here's 4, here's 5, -1, -2, -3, etc. So here's 2. So here is my border. Now, I can take any number greater than 2. And the way that we denote on a number line, including a number, is using a closed dot. So I want to include 3. I want to include 4. I want to include 5. I want to include 6. I want to include 7. And I want to include all of those over there. I also want to include 3.5, 4.5, 5.5, 6.5. I want 2.5. I also want 2.75. I want 2.6. I want 2.7. I want 2.8. I want 2.9, 3.1, 3.2, 3.3, 3.4, 3.6, 3.7, 3.8, 3.9, and we can keep going and picking values. But you'll notice that this actually becomes a solid line, because not only am I then picking 3.1, 3.2, 3.3, it's 3.111, 3.112, 3.113, 3.114. So it's literally every possible number in between. And then as well, I'm going closer and closer and closer and closer to 2. Now, this number is extremely close to 2, but it's still greater. Is there any number smaller than this that is still greater than 2? Well, of course. All I need to do is add another 0, and 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 another 0, and another 0, and another 0, and another 0. And therefore, I could add zeros infinitely. As long as they are before this 1, this value will still be greater than 2, which means that I'm actually unable to put a last point on this line before hitting 2. So what I do to say that I'm excluding 2, but including everything around 2, is I use an open dot. So I use an open dot on 2, and then a solid line to say that I'm including everything, and then an arrow on the end to say that this line of including everything is continuing. What happens if it was greater than or equal to 2? How is this different to just strictly less than? Well, it's different because I now have one singular more point, and that is the actual value of 2. And to be specific enough that we include 2, we literally make a colored dot like this on 2, and then the arrow. So just to tidy this up a little bit for you, all right, and we put the purple back. There's 2. So what we do is, if we have x just greater than 2, it is an open dot with an arrow going to the right. And if indeed you want to include 2, over there, all you do is you make this a closed dot to say I want to, and then everything greater. And the exact same thing works if you want to do something less than. So if I have an example here of x less than minus 3, here's my minus 3. Am I including minus 3? No, because there's no less than or equal to sign. So this is going to be an open dot on minus 3, and I want less than. I know I want less than because minus 3 is being eaten by the crocodile. Therefore, minus 3 is the biggest number possible. And therefore, I want everything that is smaller. Therefore, my arrow goes to the left. If I want to include it, then all I do is I make a closed dot. Now, you can also get something called a compound inequality, which is where you have 2 inequality signs at once. So this x is now squeezed between the -2 and the 3. So this, whatever value this is, it needs to be greater than -2, not equal to it, but it also needs to be less than or equal to 3. So at -2, I don't have an equal to, which means it's going to be an open dot. And on this side, I have an equal to, which means it's going to be a closed dot. And I want everything in between those two values. So there is a straight line between them. Importantly, there are no arrows here because we're not going on to infinity anywhere. We are limited within these bounds. You could have something like the following. If I say to you, 2x minus 5 is greater than 3, and I say to you, solve this. Well, how are we going to do that? Well, this inequality acts very similarly to normal equations. So if you imagine for a second that you have 2x minus 5 equals 3, and I say to you, solve this equation, you can do that. You know that this minus 5 needs to come away from that side onto the other side. When it moves, it becomes a plus. 2x equals 3 plus 5 is 8. Divide by 2, x is 4. How is an inequality different? Well, the inequality is different in the sense that what your answer looks like is going to be different. And there is one additional rule that we're going to look at in the next example. So we have 2x minus 5 greater than 3. We take the 5 over. Again, it becomes a plus. So 2x greater than 8. We divide by 2. Importantly, the 2 is positive here. And then x is greater than 4. So that's not a problem. It looks like exactly the same thing. Except here we have one answer. Here, with a number line of 4, we're not including, so it's open and to the right. Okay, we can understand that. What happens if we have a negative number here? So what happens if it's minus 2x minus 5 greater than 3? Take the 5 over, not a problem. But now we've got to divide by the minus 2. And when we divide an inequality by a negative sign, we swap the inequality sign. Very important. So if I'm dividing by negative 2, 8 over negative 2, and 8 over negative 2 is negative 4. This sign changes to the opposite. Now, why is that? Because when we divide by a negative, you're actually changing the position on the number line. Because remember, you go 3, 4, 5, 6, and smaller, bigger, bigger, bigger. But on a number line here, where you have numbers such as minus 4, minus 3, minus 2, if you go further negative that way, you're actually getting smaller values compared to bigger values. And that's why we've got to change our sign. So please make sure you are very careful with that. If you don't want to do it like that, that is fine, because we can actually move stuff to the other side. So if we still have the minus 2x greater than 8, we take the minus 2x to this side and the 8 to that side. So it's minus 8 greater than 2x. Divide by 2, and here I'm dividing by positive. So therefore, it's minus 4 to x, which is actually exactly the same answer. The sign is open to the minus 4. The sign is open to the minus 4. Exactly the same answer. All right.